In December 2025, astronomers spotted something that shouldn't exist, a comet with a tail pointing toward the sun, not away from it, toward it. Now, if you remember anything from high school physics, you know that's impossible. Solar radiation pressure pushes material away from the sun, always. It's one of the fundamental rules of how comets work. But here's where it gets weird. This isn't just any comet. It's 3I Atlas, the third confirmed interstellar visitor to our solar system. And this thing is breaking rules we didn't even know could be broken. See, when scientists first detected this anti-tail jet back in July, they thought they understood what was happening. A simple ice pocket sublimating on the sunward side. Standard comet behavior, but then they kept watching. And what they discovered changed everything. Because this jet, this impossibly collimated beam of material stretching over 300,000 miles into space, it's doing something that has a 1 in 40 million chance of happening naturally. I'm going to show you exactly what that means. But first, we need to understand what makes 3I Atlas so different from every other comet we've ever studied. If you're as fascinated by this as I am, go ahead and hit that like button and subscribe, because this story gets even stranger. Let's back up for a second. In 2017, we detected our first interstellar visitor, Oumuamua. Weird shape, strange acceleration, gone before we could really study it. Then in 2019, Comet Borisov showed up. More normal, definitely a comet, but still fascinating. Now it's 2025 and 3I Atlas has entered the chat. Discovered on July 1st by the Atlas Survey System, this object immediately raised eyebrows. Its trajectory was hyperbolic, meaning it's not gravitationally bound to our sun. It came from somewhere else in the galaxy, swung through our neighborhood, and it's heading back out into deep space. But unlike Oumuamua, which we spotted after it had already passed Earth, this time we were ready. We've been tracking 3I Atlas for months, and what we've learned is unsettling. The object reached its closest point to the sun, perihelion, on October 29, 2025, at about 130 million miles. That's roughly the distance between Earth and Mars. Here's what normal comets do. As they approach the sun, ice on their surface heats up and sublimates, turns directly from solid to gas. This creates a cloud of material around the nucleus called a coma, and solar radiation pressure pushes that material away from the sun, creating a tail. Always away. That's Physics 101. But 3I Atlas? It's got a jet pointing toward the sun, an anti-tail. Now, anti-tails aren't completely unheard of. Sometimes you can get a visual effect where dust particles in a comet's orbital plane create an illusion of a sunward tail. It's a perspective trick, like how railroad tracks appear to converge in the distance. But this isn't that. This is a physical jet of material, tightly collimated, meaning it stays narrow and focused, extending over 300,000 miles. That's farther than the distance from Earth to the Moon. And it's pointing directly at the sun. So how is this possible? The answer lies in something called a wobbling high-latitude jet. And this is where the physics gets fascinating. See, 3I Atlas is rotating, like a spinning top. And near one of its rotational poles, there's an active region, probably a pocket of volatile ices like CO2, that's venting material into space. As the comet rotates, this jet wobbles around the rotation axis like a garden sprinkler. Astronomers at the Tide Observatory in Spain tracked this wobble over multiple nights in July and August 2025. They measured the jet's position angle, basically which direction it's pointing, at a distance of about 3,700 miles from the comet's center. And they found something remarkable. The jet's position oscillates in a predictable pattern with a period of 7.74 hours. That's half the comet's full rotation period of about 15.5 hours, which means the jet base is located within 8 degrees of one of the rotational poles. But here's the kicker, and this is where probability becomes a problem. The rotation axis of 3I Atlas is aligned to within 8 degrees of the sunward direction. Let me explain why that's bizarre. Imagine you've got a spinning football flying through space. The chances that its spin axis, the line running from tip to tip, would randomly point almost exactly toward the sun as it enters the solar system? About 0.5%, 1 in 200. Now, the chances that there's an active ice pocket within 8 degrees of that pole? Another 0.5%. Multiply those together, and you've got a 0.0025% chance. 1 in 40,000. But wait, it gets worse. Because after 3I Atlas swung around the sun at perihelion, something incredible happened. The anti-tail is still there, still pointing at the sun, But now the comet is moving away from the sun, which means the side that was in shadow before perihelion is now facing the sun. That means there's a second active region near the opposite pole doing the exact same thing. The probability of both of those happening by chance? 0.000025%. 1 in 4 million. Now, I know what you're thinking. Okay, so it's unlikely. Unlikely things happen all the time, right? Sure, you could win the lottery. Lightning could strike the same place twice. But when you're a scientist and you see something with a 1 in 4 million chance of occurring naturally, you start asking a different question. What if it's not natural? And that's where Harvard astrophysicist Avi Loeb enters the picture. Loeb has been studying 3I Atlas intensively, and he's compiled a list of 15 anomalies, 15 things about this object that don't fit the standard comet model. The aligned rotation axis is just one of them. Let's talk about some of the others, because when you add them all up, the picture gets even stranger. Anomaly number 1, the trajectory. 3I Atlas is on a retrograde orbit aligned to within 5 degrees of the ecliptic plane, the flat disk where all the planets orbit. The chance of that happening randomly? 0.2%, 1 in 500. Anomaly number 2, the timing. It arrived at a point where it would pass close to Mars and Jupiter, but be unobservable from Earth at perihelion. Its forecasted encounter with Jupiter in March 2026 will bring it within 33.3 million miles, almost exactly Jupiter's Hill radius, the boundary of Jupiter's gravitational influence. Anomaly number 3, the composition. Spectroscopic analysis shows way more nickel than iron in its coma. That's the opposite of what we see in natural comets. But it's exactly what you'd find in industrial nickel alloys, the kind used in spacecraft construction. Anomaly number 4, the water content. Only 4% water by mass. Most comets are dominated by water ice. This thing is mostly CO2. Anomaly number 5, the collimation. That anti-tail jet stays narrow within 8 degrees, out to 300,000 miles. Even after perihelion, even with solar radiation pressure and solar wind trying to disperse it, it maintains its tight beam. For a natural outgassing jet to stay that collimated, you'd need a very specific geometry, like a nozzle, like a thruster. Now, here's where I need to be clear. The scientific consensus is that 3I Atlas is a comet. NASA held a press conference and stated that its qualities can be naturally explained by its different birth environment. And that's a fair point. This object formed in another star system. Maybe the conditions there were different. Maybe the chemistry was different. Maybe we're just seeing what comets from other stellar neighborhoods look like. But Loeb and his colleagues have done the math. And when you multiply all these probabilities together, the trajectory alignment, the rotation axis alignment, the dual jets, the composition, you get a combined probability of about 1 in 4 billion. At what point does unlikely become we should consider alternatives? Loeb isn't saying it's definitely artificial. What he's saying is that the probability is low enough that we should investigate seriously. We should point our best telescopes at it. We should gather as much data as possible before it leaves the solar system forever. Because if there's even a 1% chance that 3I Atlas is something other than a natural comet, if it's a probe or a derelict spacecraft, or something we don't have a category for yet, then this is the most important discovery in human history. So what happens next? Right now, 3I Atlas is moving away from the Sun, heading toward its encounter with Jupiter in March 2026. It's still visible to large telescopes, and astronomers around the world are watching it closely. The James Webb Space Telescope could potentially observe it, using its infrared capabilities to measure the object's temperature, size, and composition in unprecedented detail. Spectroscopic studies could tell us more about what's in that jet, whether it's just sublimating ice or something else entirely. And here's the thing. We're entering a new era of interstellar object detection. The Vera Rubin Observatory, which just came online, is expected to find dozens or even hundreds of these visitors over the next decade. What seemed rare in 2017 is about to become routine. Which means if 3I Atlas really is anomalous, we'll have other objects to compare it to. We'll be able to say, okay, this is what a normal interstellar comet looks like, and that is what 3I Atlas looks like. The anti-tail of 3I Atlas defies our expectations. Whether it defies physics depends on what it actually is. A comet with an incredibly unlikely geometry? Possible. Or something else entirely? Also possible. The data is still coming in. The story isn't over. But one thing's for certain, we're watching something extraordinary. And in a few months, when 3I Atlas passes Jupiter and heads back into the darkness between stars, we'll have our last chance to find out what it really is. The universe just handed us a mystery. Let's hope we're smart enough to solve it. Before you go, I want to hear from you. If this video got you thinking, hit that subscribe button so you don't miss our next deep dive. Drop a comment below with your theory about 3I Atlas natural comet or something more. And if you know someone who'd be fascinated by this, share this video with them. This is the kind of story that deserves to be talked about.